Hey guys, today we are going through the next part of the Alleyn School Maths sample paper. So let's get straight into these solutions. Okay, so here we have to try and work out what's going on and the patterns in these sequences. And when we work out this pattern, it will help us to work out the missing numbers or the next two numbers in the sequence. So first one, 7, 10, 13, 16. Nice and easy, simple addition. We're adding 3 each time. So it should be 16 plus 3, 19, and then 19 plus 3, 22. Then we have 53, 49, 45, 41. Now we're subtracting, but again, it's the same number each time. Super easy. We like these kind of questions. Subtracting 4 from each number. So now we have 41 minus 4. Giving us 37. Be careful when we're going backwards, not to make any silly mistakes. And then we have 37 minus 4, giving us 33. Now we have 6, 10, 15, 21. Well, let's look at the difference. Plus 4, plus 5, plus 6. Okay, we can see what's going on here. It's going to be plus 7 and then plus 8 to continue that pattern. So plus 7 is going to be 28, plus 8 is going to be 36. Awesome. Next one, we have 60, 58, 63, 61. What's going on here? At first, it seems a bit confusing because we're going down and then we're going up and then we're going down. I mean, it's 8 and then it's minus 5 and then it's 2. What's going on? The key here is to understand that the relationship is between every other number, not consecutive numbers next to each other. So here, the relationship is 60 to 63 because we're adding 3. And then we have 58 to 61. Again, we're adding 3. So now we can continue this pattern to find both our numbers. Plus 3, plus 3. So 63 plus 3 gives us 66. 61 plus 3 gives us 64. So those are our answers, 66 and 64. And it's from recognizing that the pattern is between every other number. So watch out for that sometimes when we see it in the exam. Now we have 0.5 to 832. So here the numbers are getting very big very quickly, right? From 0.5, half of 1, all the way to 2, then 8 and 32. So there has to be some sort of multiplication going on here to make those numbers get very big very quickly. So here, if we look closely, we're multiplying by 4 each time. 0.5 times 4 gives us 2. 2 times 4 gives us 8. 8 times 4, 32. 32 times 4 is what? Well, let's use our mental maths. 32 times 4 is 30 times 4 plus 2 times 4, right? Because 32 is 30 and 2. 30 times 4 is 120. To make it simpler, 3 times 4, which is 12. So add a 0 because we're doing 30 times 4. So 120. Then we have 2 times 4, which is 8. So 120 plus the 8 gives us 128. And then we have 128 times 4. Here it might be quicker to do it using our normal method, our non-mental maths method. 8 times 4, 32. Carry the 3. 2 times 4, 8. Add the 3, 11. 1 times 4, 4. Add the 1, 5. 512. These are our answers. Okay, so now we have to put the following in order, starting with the smallest. And again, we're going to draw upon our knowledge from the decimals questions beforehand. Different columns, tenths, hundredths, thousandths, so on and so forth. So here, starting with the smallest, well, we're going to start by assessing the tens column, because all these numbers don't go past the tens column, not tenths, tens. So on the left-hand side of the decimal point. Here, we have no tens, 0 tens. Here we have 5 tens, 3 tens, 0 tens, 5 tens, 0 tens. Okay, so smallest is going to be one of these numbers with 0 tens. So now let's move to the units column. Here we have 3, then we have 5, then we have 5. Okay, so smallest is going to be this one here with the 3 as a unit. We don't need to look any further to the right-hand side. So smallest, 3.55. Now let's look to these two ones that have 5 in the units column. We have 5.35 and 5.53. Well, in this tenths column, 3 is smaller than 5. 3 tenths is smaller than 5 tenths. And therefore, this is the next smallest number, followed by this one. So now we've counted out these numbers. Let's move to these next ones. We have 53.5, 35.5, 55.3. Well, here, if we look at the tens column, we see the 3 is smaller than the 5 and the 5. So this has to be the next smallest number, 35.5. Then we have 53.5, 55.3, units column, 3 smaller than 5. So we don't need to look any further. It has to be 53.5 and then 55.3. This is our order from smallest to biggest. Okay, so for this next question, we have to draw lines of symmetry on these shapes. And we're told already that some may have no lines of symmetry and some may have more than one line of symmetry. So when we're thinking about lines of symmetry, don't get thrown off and think it's so complex. The main thing I want us to think about is drawing lines that cut through the shape, that if we were to fold that shape over that line, there would be no overlaps. When you think about lines of symmetry in this way, it makes it so much more simple. For each of these shapes, we're trying to draw a line where if we fold the shape on that line and we fold it over, there would be no overlaps. So here, for part A, we have 2 lines of symmetry. You can see I've already drawn one. Line is not perfect, but you can see here, this is our first line of symmetry, because if we were to fold this part over this line I've drawn, you can see there will be no overlaps. This section here would perfectly line up with this section here, and therefore it's a line of symmetry, right? It's almost like you're drawing a line where each side is a perfect reflection of the other. So the second line of symmetry would be over here, across this diagonal. Because again, if we were to fold this shape on that line I've just drawn, there would be no overlaps. So for this question, you don't have to get it exactly right to the millimeter, but generally you want to show the examiner that we understand what's going on. And we understand there's one line of symmetry roughly here from top left to bottom right, and there's one roughly here from top right to bottom left. Now for B, this is more of a tricky one because there isn't really any line of symmetry. We have a very irregular looking shape, and therefore there are no real lines that we could fold this shape on where there would be no overlaps. Perhaps you could argue for this line here, but these two sections of the shape don't really seem equal enough for us to fold over one section and for there to be no overlaps. And therefore for B, I would say there are no lines of symmetry, no lines where we can fold the shape over those lines and there will be no overlaps. So let's leave B with nothing. C, we do have a line of symmetry, and it's going to be right here across this diagonal. We can see it passes our test. If we were to fold this bit over and collapse it over here, there'll be no overlap. This section here would perfectly align with this section here, and therefore we know it truly is a line of symmetry. And finally, for part D, we have this parallelogram. So for this shape, we actually have no lines of symmetry. There are no lines we can draw on the parallelogram where we can fold the shape over that line and there will be no overlaps. We can't do it across this diagonal because if we fold it over, it won't exactly line up. And same thing with this diagonal. So, same thing with directly vertical or horizontal. It just doesn't work. So we need to remember and understand that when it comes to parallelograms, we have zero lines of symmetry. So this will be our final answer. A, B, C, D. A and C have lines of symmetry. B and D are parallelogram, do not have any lines of symmetry. Okay, so here we have to reflect shape A in the x-axis. So let's do that. We have the x-axis right here. So let's take it point by point. We don't rush these reflection questions. We take it step by step. And doing that means we can come away with the correct answer. So here we're 1 away from the line of reflection. And therefore, we do the same thing on the other side. So here is our first point of our new shape. Same thing here, 1, 2, 3, line of reflection. Put it in red. In our new area, same thing, 1, 2, 3. Next point. Here, we are 1, 2 away from the line of reflection. So again, 1, 2. Here's our new point. And once we connect them, we have our new reflected shape. And we call this new shape B. Then for part B, we're going to reflect shape B in the y-axis and label this new shape C. So same thing, we have our y-axis here, right? X and Y. This is the Y. So step by step, same thing. 1 away from the line of reflection. So again, we're going to go 1 away, new point. Here we are 1, 2, 3 away. So we're going to go 1, 2, 3 away. Then here we are 1, 2, 3, 4 away. So we're going to go 1, 2, 3, 4. Here's our point. Connect these points. 2, 3, and this gives us our new reflected shape, which we label C. Here is our answer. Always take these questions step by step. Okay, so now let's go through question 17. Steve has counted the number of goals he scored in 6 five-a-side football games. And the counts were 3 goals, 4 goals, 2 goals, no goals, 1 goal, and 8 goals. Okay, so we have that data, that information there. First, we have to work out the mean score for the games he counted. So for the mean, how do we work this out? We take the total and we divide it by how many data points we have, how many values. Number of values. So here, what's the total? What's the numerator? Well, we have 3 plus 4 plus 2 plus 0 plus 1 plus 8. So mental maths. 7, 9, 10, 18. So total 18. How many games did he count? Well, we're told it's 6. So 18 over 6 should give us 3. So the mean score was 3 goals. And then what was the range? Well, for the range, it's always the largest minus the smallest. And that's going to be the 8 goals he scored minus the 0 goals he scored. So the range is 8 goals. And now for part C, we're adding a bit more complexity to the question. In the next game, he scored enough goals to increase his mean, which was 3, to 4. How many goals did he score in the 7th game? So to answer this question, we need to understand this formula we use to calculate the mean on a deeper level, right? Because we're given some more information. We're told the mean is now 4. So the total over the number of values, or in this case, number of games, is no longer 3. It's now 4. What else do we know? Well, we also know the number of games has increased, right? It's gone up because he's played an extra game in the next game. So now we have not 6 games, but 7 games. So let's just take it step by step and rewrite this formula. The mean is going to be total goals scored over number of values, number of games, which in this case is 7. And we're told this mean has increased to 4. So how many goals did he score in the 7th game? Well, if we rearrange this equation by multiplying both sides by 7, we work out that the total has to equal 4 times 7, which is 28. So before, our total was 18, remember, for the 6 games. But now we've played 7 games. Our total for this to work has to be what? 28. So we've gone from 18 to 28. So knowing that, how many goals must Steve have scored in the 7th game? It has to be 10. That's the only way to bump up, to increase our total enough to increase our mean to 4. And that's how we work it out. 10 goals is our answer. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.